Hello, everybody. Welcome to Data Umbrella's webinar, our first of 2025. I'm going to do a brief introduction, and then Roy will be doing his presentation, and we will be answering questions as we can, either along the way or towards the end. This is being recorded. Data Umbrella is a community for underrepresented persons in data science, and we are a nonprofit organization. This is our team that makes it happen behind the scenes. My name is Reshma Sheikh, and Beryl is our next team member who's based out of Nairobi, Kenya. Christina is based out of New York, and Sangam is based out of India. We have a code of conduct, and we thank you for helping to make this a welcoming, friendly community for all. There are various ways to support Data Umbrella. The first and foremost is to follow our code of conduct. And we love it if you could share our events with other people in your network. We also have quite a few projects on our GitHub, such as our blog and our website, that you can contribute to. Here are some of them. You can donate to our nonprofit. We are on every.org at Data Umbrella. We have a very rich library of high-quality data science videos on data science, Python, RStats. I'll share the link. Feel free to subscribe to our YouTube. We also have a lot of playlists that will be of interest. One of them is career advice. Another is data visualization, contributing to open source and other projects such as scikit-learn, PyMC, NumPy, and more. We also have a monthly newsletter. We're at dataumbrella.substack.com, and we aim for the first of the month. These are our most commonly used links. This platform that we're using has live captioning. So on the top right, if you see CC for closed captioning, that will give you a live transcript of the presentation. We also have an online suggestion box if you're interested in sharing ideas for future topics or speaking at a webinar, and I'll share the link to that in the chat as well. Today's talk is Make Your Own JupyterLab Extension with Roy. I should have asked how to pronounce your name there, Roy Hyunjin Han of CrossCompute. Roy is, for the past several years, Roy has been working on CrossCompute, a distributed computing platform for deploying decision support tools. He is interested in infrastructure planning and hazard mitigation. You can find Roy on LinkedIn and other platforms such as X and GitHub. And with that, I will hand over the screen share and microphone to Roy.
Hi, thank you, Reshma. Let me put on the screen share. Thank you to Reshma Sheikh for inviting me to present today's Data Umbrella tutorial. I'm just checking the mic. My name is Roy Hyunjin Han, and today I'll get you started on making your own JupyterLab extension. My mission is to inspire people to make tools that improve health, safety, quality of life. You can find me on GitHub and LinkedIn as Invisible Roads. My office is in the ARC Innovation Center, formerly the Tampa Bay Innovation Center of St. Pete, Florida. For the past several years, I've been working on the problem of how to share runnable tools. CrossCompute is a specification and architecture for turning Jupyter notebooks into runnable tools. On the right is an example of a runnable tool, and on the left is its CrossCompute specification. A quick note on how the journey up to Jupyter is we started out with a closed source platform for hosting decision support tools, and then we took parts of it and created a simplified open source version of it. And later on, we integrated it with Jupyter Notebook and then JupyterLab so that people could create web-based tools from their Jupyter notebooks directly within the Jupyter development environment and automate the reports. We're currently in the early stages of creating a peer-to-peer server as well. You can find these packages online at JupyterLab at -CrossCompute. That one currently it only supports JupyterLab version 3. We're in the process of updating it to JupyterLab 4. And our other open source package is CrossCompute-Analytics. And you can try our server at crosscompute.com. Today, you can try 3 of these tools on our platform. One is a tool that you can use to try different JupyterLab extensions without installing them on your own computer. You'll see it soon. You can also try our extension, as well as we'd like to introduce a tool that you can launch a machine with a command line so that you can do more intense. We use it primarily for pair programming within our team. All right, so today's topic, make your own JupyterLab extension. We'll start by giving a brief overview of the history of Jupyter Notebook or IPython Notebook and its difference with JupyterLab. We'll go through some useful extensions, and then we'll make an extension. And I'll give some tips about that. So if Jupyter, the original, one of the original early creators of IPython, Mr. Perez, his vision was to create an interactive programming experience. So he, with Brian Granger and Min K, they created a system that is really great for mini iterations. It's great for prototyping and exploratory data analysis. So IPython, you see it's still being very useful. And then they expanded it to be in a web form in IPython Notebook. And then they announced later they expanded support for Julia and R as well, and it became Jupyter, and then JupyterLab. So this is the current version of Jupyter Notebook. It's a single document. Currently, JupyterLab supports over 176 kernels. Kernels are like different programming languages, including Go, C, Lisp, you name it. So this is the JupyterLab environment. Unlike Jupyter Notebook, you can have multiple panels that you split. This is your main work area. You can, by dragging the tab, you have a left sidebar, which is the file browser, and a right sidebar, which has to do with the contents that you're working with. So some features that are pretty recent, they've added a mini map. So this mini map is you hit the 3 hamburger button on the right, and it'll kind of show you a preview of the code execution state, and you can click on them too. That's pretty cool. They've added workspaces. So these workspaces are automatically created when you, for example, have a layout like this. So when you click on it, it'll pull up the files that were open at that time, diagrams and markdown, an inline completer so that, more generative stuff if you're into that. And this they've had for a while now, real-time collaboration. You can try this on our site. So this is kind of like bringing a Google Docs collaborative experience to Jupyter Lab. You do need to install the Jupyter collaboration package for this to work. and an extension manager. The extensions that are shown in the extension manager have this PyPy classifier on them. So if you think you've built something that's pretty interesting, just add this and it'll show up. So some basics, a quick refresher. So pip install JupyterLab. We've got code cells, markdown cells. And you can try this right now. So Shift Enter, the Control Enter, Alt Enter, these all run the cells. So Shift Enter runs and goes to the next one. Control Enter runs that current cell, and Alt Enter adds another cell block. You can restart the kernel. Tab for auto completion. Shift Tab for tooltips. Let's catch up. So tooltips, undo, redo. You can insert cells above and below, change them to markdown, and to render it, you execute it. You can split cells and merge them just by selecting them with the Shift button, Shift up, Shift down. So we merged it with Shift N, and we split it with Control Shift minus. And you can block comment and uncomment with Control \. And finally, there's if you're into more advanced commands, Control Shift C to pull up the command palette. So just type in what you want to look up, and then you can quickly either press Enter or press the shortcut for it. If you've worked with Jupyter Notebooks for a while in version control, you'll know that it's a bad idea to commit the outputs to it, not only because it has sensitive information, but also it makes calculating the differences in GitHub difficult. So I recommend either manually clearing the outputs before committing to GitHub. You can also just run a command like this. You can find this in our GitHub Invisible Road scripts folder repository. So what this does is it'll recursively search through all the IPython notebooks and clear the output. So that's in a bash command we have. If you can also, we created a pre-commit hook for that, so that before each commit, it'll automatically clear those notebooks outputs. So that's pretty, you can find these pre-commit hooks on our GitHub Invisible Roads. This is my username. Another thing that's useful before as a pre-commit hook is there's a package called NBQA. If you're familiar with linters like PyFlake or PyLlama, there's NBQA. So NBQA has more than this. That has auto format, and I don't really like auto formatting my code, but PyLlama will check for syntax errors and stuff in your notebooks. And this is good, especially if you produce notebooks for let's say the notebook is your product that you perhaps give to students and stuff. So once you've cleared the notebooks, it's still not really good in the Git diff, because a notebook is a JSON document. So there is a package called nbdime or nbdme. To enable the Jupyter extensions, you need to run this command, and it'll produce something like this, where you can compare different commits and see the changes both in the outputs as well as the code. Yeah, and I should mention the debugger. So in order to activate the debugger, you need to install a package. If you're doing Python, there's a package called XEUS Zeus Python. And that will allow you to open this debugger in JupyterLab on the right. You can set breakpoints, you can watch variables, step through your code, everything you're used to in a debugger. You just need to, what you need to do is pip install it, and then you need to select the kernel for your notebook to be Zeus Python, and I could demonstrate that later. So that was the section on JupyterLab Basics. Are there any questions that people would like to ask? We'll take about 3 questions before we move to the next section.
No questions so far.
Okay, so we'll go into the next part. So this will be an overview of useful extensions. There's currently over 600 or so extensions. You can, let me see if I can pull, oh yeah, here. So you can try the extensions, different extensions right now without installing them on your computer. We have a tool on our site at crosscompute.net called Try JupyterLab Real-Time Collaboration. So when you start it, you don't have to sign in, and you go to the left here, and you can search for a extension such as the JupyterLab Vim extension, and click install, and you can try it out. You do need to refresh the page. And then when you open the notebook, you'll be able to, you see it's got a Vim interface with Vim keys. Well, I think we also show you how the interactive matplotlib extension called IPyML, MPL. So yeah, you can go to crosscompute.net to try this out. It's a secure sandbox. So this is just another example extension, and it lets you add a little bit more interactivity to your matplot plots. So you can kind of, it shows you the value. So we split up the useful extensions in categories. Plotting, IPyMPL, that's interactive matplotlib. IPyDataGrid lets you see like these kind of, I don't know how to put it, but you can kind of slide these widgets and see the different changes. These are taken straight from their docs. So I thought that was pretty cool. IPyWidgets add interactive, so you can kind of move your plots in different ways. This is for mapping. 3JS is a popular visualization library if into more. Let me see if I can get on this link. Well, this is more intense visual stuff like 3D rendering. More mapping. This has more deck GL stuff. So we can look into that. I don't know if I can click in here, but oh, I can. Let's try this. Yeah. So PyDeck is some cool stuff, and this is, this is 3JS. But I particularly like this IPyDataGrid. For publishing extensions, I found they had a spell checker, JupyterLab, LaTeX, Jupyter Book. Also, without installing an extension, I believe Jupyter Notebook default supports MathML if you want to put mathematical formulae in. And I also want to mention our extension, JupyterLab CrossCompute, where you can turn a Jupyter Notebook or command line script into a web-based tool or PDF report. So just wanted to mention that. Yeah, it supports things like conditional templates, and you can add file uploads to your forms and other kinds of widgets. So pretty much it will let you quickly prototype a decision support tool from your script. Code extensions. I liked this LSP, so I like to think of it kind of like super tooltips. Wonder if I'm sharing. Yeah, I am sharing this. So you can hover. So JupyterLab already has tooltips, but these are deeper tooltips. They also have things like continuous hinting. So normally you'd have to press Shift-Tab for the hint to come out, but this kind of adds a little more processing cost, but I got things like that. So I thought this package was interesting. A lot of these packages that I've listed are officially projects of the Jupyter team. JupyText converts a notebook into text if you want to. This is an alternative to using an NBDime or NBDime for diffing, because you can diff the text. This is like a find, replace, and so this was an interesting project. What it does is it, if you're kind of not in order, you might run your cells, but then you run gather, and it kind of puts them in order depending on how you ran it. So it's an interesting project by Microsoft is doing it, and then you have things like Jupyter AI, which is very early stage if you want to plug in those generative models. They also have some JupyterLab Git extension. It looks kind of like this, so you can do people who don't like to type and like to use their mouse. I have to confess, I mostly use the vanilla JupyterLab, other than our own extension. So I'm not as familiar with these, but there are support for other GitLab and GitHub. And data, the ones I found that were interesting. So spreadsheet, for just visualizing a spreadsheet. Editor provides a kind of basic edit capacity directly in. So if you have some small files that you don't want to have to pull up your favorite spreadsheet editor, you can use that. SQL for connecting a database, and archive for being able to open and extract and compress compressed files directly within the file browser. And also this file system project that looks like JP Morgan Chase released to connect to different data stores such as S3. So I thought those were interesting. Deployment. So Jupyter Scheduler is a it's like a cron job for your, so you can schedule a Jupyter Notebook to run in the future. That's what I got the idea of, as well as Jupyter Lite. And this is a a JupyterLab that runs entirely in your browser with no server backend. It's a cool project. All right, so let's get to our make an extension. The documentation is pretty extensive. So we'll talk about that. Well, then you kind of an overview. We experiment. You should experiment with the example extensions. There's a good gallery. We'll start from the latest template, work incrementally, and finally search the standard extension. So I'll talk a little bit more about this. So read the docs. I suggest you, if you want to make, you've decided you want to make your own extension, you should start with the common extension points doc. So this is, let me kind of show it here. So let's say you wanted to extend the shell, which is the main area. It's a good place to start. I highly recommend reading it thoroughly. The extension examples GitHub repository, also you should look through all that. Before you dive into them, I think all of them have some kind of, just skim through the animations and you'll get an idea. And they even have an example for collaborative documents. You can see here. So how do you experiment with the example extensions? Well, first, git clone the repository, go into pick an example such as the signals. Signals. You install, this process could take a while, and install the front end extension and you build it, and then launch your JupyterLab. I recommend starting through the commands, signals, and React widgets. Well, I'll talk through it briefly right now. And when you look at an extension example, you should look at the entry point. So this is source index TS, that's the entry point for the front end, and package handlers.py is the entry point for the back end. So let me give an example real quick. So let's pick the signals. So how do we make sense of this? Well, first let's look at the source and the index. And I'll kind of zoom it a bit. And then we look at our entry point here. And then to understand the back end of it's typically in some package like this, and then handlers is where the back end tornado routes are defined. They're also working on a fast API backend, but that's going to take a while. All right. So if you want to try these out, the extensions right now, and you don't want to install it on your own computer, we do have a tool, pair program, crosscompute.com, pair program you can use. We developed this program to solve the problem of when we just need a temporary machine to do a pair programming 2-hour session or so. So we each put in our IP addresses and our public keys, and then it boots and what ports we want open to which IPs. You can also put 0.00 if you don't want an IP address restriction, and how many minutes you want the machine to be up for. And it'll just boot up a machine with those security restrictions that you can SSH into, and tell you which ports which IP ports you can use to sign in. So once you're in, the commands, before I gave you, well, I'm sorry. I'm sorry, I didn't know that I wasn't showing you this. Let me try again here. So this is the tool. So yeah, put in your IP addresses you want to access from, your public keys, and which ports you want open. And it'll give you an SSH command, as well as something you can paste into your browser to go in. So The commands here are different, slightly different from the commands I gave for the just your on your own machine. So on the remote machine, you need to give a port as well as which IPs can access it. Yeah. Oh, and this process will take a while if you do use our tool. It'll take about 7 minutes. So be patient. Okay, so if you are trying that that tool, while you're doing that, let me just mention the entry point. So the front end entry point will look something like this. Jupyter front end plugin. These are the widgets that it depends on. Here's your app, and then these are in the same order as your requires, and there's also can be an optional section here. So that's how you can read the front end entry point. So once you've started the machine, or on your own machine, you can, and you're ready to start. They now they use copier instead of cookie cutter, but you'll start from this template. So a template, this is a GitHub repository. So run this command, and it'll come up with something like this where you can pick your, so we'll pick in a server extension, and then you need to run these commands to set it up. So install it in editable mode, enable the server extension, build it the first time, and then this is a long-running watch process that auto recompiles your JavaScript. And I believe this auto reload is a new directive they gave, so that if you update the server code, it'll also relaunch the server. In the past, you'd have to kill it and restart it. So the combination of these things should provide you with a more streamlined extension development experience. So let's go into the details of today's simple extension. So we're going to add a right sidebar. And the way we'll do that is by, so remember, this is the entry point. And we take app.shell and we add a panel, a right panel, and this is the order that the panel will appear. And when you do that, you'll come up with something like this, and you see it, that's what you get. So next, listen for events in the shell. So we want to connect our extension to other widgets in the front end. So in this case, we're connecting it to the lab shell. And so whenever somebody opens something, another document in the shell, we console log it. So this event, console log, we move incrementally from console log to actually showing something. So here is an example of the panel as a React widget. So you would need to label your file as extension.tsx and kind of set an ID. You can set an icon optionally and a render. And then what you want to do is have your React widget update in response to changes in other parts of the interface. So to do that, we're going to use signals. So signals are an important concept in the extensions, and it's how the different widgets communicate with each other. So we put a use signal because we're using React. And what this just means is that when the model changes, when the changed signal is emitted, then it updates whatever's in here. So when the model is changed, then it just refreshes the lab shell path. So that hooked up, this is the definition of the model. So here's our signal. And when we set the lab shell path, we call update, which emits the change signal. So just to repeat it, when you update the path, it emits a signal and it refreshes inside here. And you get something like this where when you open the files, you see it's kind of updating here. So the next step, we want to listen kind of events in another widget. So similarly, the signal for file browser, whenever you open another folder, is file browser model.path change. So I'll show you how you can find out what the signals for each component are. But when you rely on a signal from another widget, sometimes the compiler will emit a warning, so like module not found, and that probably means you need to add a dependency. So do something like jlpm add file browser, and it'll add the dependency, and that should fix the error. And then what you'll get is something like this, where it's listening both to what folder it's in, as well as what file is opened in the middle. So you can also link. Well, I know I'm going kind of quickly. I should ask if there's any questions before I keep going.
No questions so far.
Okay. So now I'm going to show, so your widget can now respond interactively to other widgets in your interface, but now let's say you want to act on other widgets. So here we're creating a link that when you click on it, it opens that file up in the shell. So how does that work? So this is, we add another dependency on document manager, and when we call that, it runs this function. So yeah, so what it does, it takes a current folder and opens the README, and it also there's some CSS styling to it. So to update the CSS styling, you go into Styles, Base, and so this might seem all archaic. I'll show you where in a little bit, but here's what it looks like. When you click on the link, and it opens a README. So that's how you can cause changes in other parts. And finally, a way to call the server. Let's say you wanted to make some server-side call. Here we're going to add a button that when you click on it, it makes a request to your server extension and shows what it got back. So this is a server. Remember I said the server, you look in handlers, and it's a Tornado backend. You need to preface with the authenticated decorator. This is important. It protects your view from, make sure that the user is authenticated. And you end with a finish, and you can respond with JSON or however. Your server could reply with WebSockets or server send events. It's a little bit more involved, so I won't go into that. But you can see all this code that I'm going over right now is in our JupyterLab -CrossCompute repository. I guess I should show you where that is. So here, It's in the a specific branch, the 2024-07. Let me go to it. 2024-07 branch experiments, and this one, so you could see the commit history. You can see all the examples here. Yep. So to go back to this, so when you finish this button, what it'll do, you click on it, it calls the server, displays the result from the server. So you could use this, for example, if, I don't know, you're making an API call on the server. All right, so all of that might have seemed archaic, but it actually, you can find it all by going into JupyterLab, the repository, and going into the packages and just grepping for something you need. So let's say I wanted to find out what kind of signals are in the file browser. You go into the package, I grep file browser, and then I see some, I mean, these are my shortcut commands. It's actually, this is approximately what it runs. So this one will search for file browser recursively in all your files, ignoring binary files, showing line numbers recursively. And this one will just take the output of that and edit, open all of them at once. So then you come up with something like this when you run the first command. And then you look at it more carefully, and you can see how the Jupyter engineers structured the code. This is the contents of that JupyterLab packages folder. It looks like this. Perhaps you can guess what a lot of these are. And everything that you see in JupyterLab is an extension. They've ingeniously designed the architecture that way. So for example, I mentioned the file browser, the status bar, table of contents that's on the left, the notebook itself is an extension, these two combined, the cells. So it's pretty amazing what they've done with all that grant money. So yeah, more resources. I highly recommend the Jupyter discourse forum. Let's see if I can pull it up. It's documentation. Check the data umbrella YouTube. We also have a discourse forum for updates regarding our work, and a YouTube channel. I'd like to thank Abdurrahmani Sakasani for a lot of his work on the tools, and Reshman Barrow for organizing this webinar. So I can take some questions or go over some parts that perhaps I went a little too quickly.
So no questions so far?
Okay. Thank you very much then for your time today.
Hey, Roy, thank you so much for the presentation. Yeah, we'll have the recording up by the end of the day, and we'll link to all the resources that were mentioned here, so people have the resources as well.
Okay.
Thank
Thank you. Mm-hmm.